There's so much to learn about thermal energy, as well as many topics relating to thermal energy. Oh, didn't see you there. But let's get straight to the point. I want to learn more about thermal energy, and I think you do too. So let's discuss a couple key points about thermal energy. These include fun facts, the whole idea of convection and conduction as it's important to thermal energy, as well as lastly an experiment to give a better grasp of what thermal energy actually looks like in a sense. The first fun fact has to do with this diagram, as this diagram shows an ice cube, a glass, and some hot water. Usually people perceive the ice cube just spreading around the hot water, causing cold temperatures in the water, but it's the other way around. Let me elaborate. To be more specific, the thermal energy from the hot water and the heat is transferred into the ice cube. So that's what causes it to melt, as the heat energy is actually just trapped inside of the ice cube, causing the water to get colder. Second fact has revolve around the Earth and its core. In Earth's core, there's a lot of heat trapped in, and it is kept there, but it can release through into space. For that, the Earth must have a balance of heat. More heat is introduced because of the sun and is trapped into this core. There's a misknown fact that what's happening in the fire is heat, but that's completely wrong. To be more specific, heat is just a process. The burning of the wood is considered to be the process, which is heat. The fire, and because it's really hot, is actually just thermal energy. So technically, you are not seeing heat, you're seeing thermal energy, in a sense. Let's talk about the process of conduction. Conduction basically explains the process in which one heat source is being transferred to an object. So a perfect example would be the diagram in front of you, as the coffee heat source or thermal energy is being transferred to the metal spoon. The metal spoon will get red, and then if you touch the metal spoon, you'll probably burn yourself or you'll get hurt in the process. That is because the metal spoon is a great conductor. A conductor basically explains something that is very easily transferable to heat. So basically what I'm saying is the metal spoon can easily be transferred heat to, as it's a great conductor, or it conducts the heat or the thermal energy. There are also examples of many things that cannot conduct heat as well as a conductor. An example of those would be something like plastic. They're actually called insulators, in fact. So that's why whenever you're cooking some food or you're making a burger, you would always use a plastic spatula. That is because the plastic won't get onto your hand and it won't transfer the heat, which could possibly burn you. And that's why whenever you're working or you're using a pot, you never ever touch the metal part of the pot when cooking, because it conducts heat very easily. So overall, conduction is basically the process of a heat source meeting with an object. Let's talk about convection. Convection is basically all of these water particles basically boiling and becoming less dense and soon evaporating. Steam shows an example of convection. So basically, there will be warmer and more energy infused particles that evaporate to the top, while the denser ones keep lowering and lowering and lowering till they're at the bottom, and then they become the energetic particles that basically evaporate. It's a cycle that explains of more denser particles staying at the top as they are colder, and more warmer particles that have more thermal energy staying at the bottom and then evaporating. The process is basically a cycle, and it continues as the more denser particles become more warm as there's more thermal energy being spread out, and those denser particles go down to the bottom of the pot. We'll use a pot as an example, and will soon evaporate. That's why whenever you're making soup, there's always steam. So basically, at the bottom, there's always these energetic and hot particles filled with thermal energy that are rising to the top and then evaporating, while the more denser particles stay at the top and then slowly get to the bottom, and then the cycle continues. As there is a heat source, there will always be convection. Today I'll be doing an experiment, basically boiling water. Boiling water will show convection, conduction, as well as thermal energy and how it spreads. I've kept it on a low heat so you guys can still see the process, but it won't boil as fast. Basically, those particles you see all the way at the end, which are fizzing and moving around and being a little more hyper than the ones at the top, are basically going to evaporate soon. And the evaporation and this whole process is called convection, as I already explained. It's easier to see in real life of how it works. Basically, there's no steam right now, but I could feel a little bit of warmness above the pot, which shows that convection is in process. If I touch the metal steel pot, then I would probably get burned. I won't do that because it would hurt, but that would show how heat is already conducted. You can't really see that heat is conducted onto the metal, but it probably is, as there's a fire running. And whenever there's a fire and metal is around, it will always conduct heat. And that's why there's a plastic guard right here. Lastly, I want to explain thermal energy. As you can see, this heat, it basically shows the thermal energy because it's transferring from the fire, even though it's still in the fire, it's transferring some of the thermal energy to boil the water. And as I already explained before, that's the whole process of convection. So in a sense, this wraps up everything. And this experiment can finally explain about everything regarding thermal energy, convection, and conduction. I hope you guys are more interested in thermal energy and are eager to learn even more about it, as thermal energy is a very interesting and broad topic, and there's many different things you could specify on and work on, as it basically revolves around our whole entire world. To get started and learn more about thermal energy, you could even ask a simple question like, "Okay Google, what is thermal energy?"
According to Wikipedia, in thermodynamics, thermal energy refers to the internal energy present in a system due to its temperature.